In this problem, it states a syringe containing 3.75 mils of chlorine gas is cooled from 75.2 degrees Celsius to 12.5 degrees Celsius. What is the new volume of the sample in the syringe? Now, this problem doesn't give you a unit, so I would accept it in milliliters or liters. Likely on an exam, you would see that it is either going to ask for something or I would be somewhat flexible on the units. So we need to ask ourselves, what is this asking? So we're asking for a new volume. We have a volume and we have two temperatures. This is one of the gas laws. So we know that volume and temperature are inversely related. So V1 over T1 is going to equal V2 over T2. Whoops, that should be a 2. So one of the things we need to ask ourselves is what are all these numbers? So we have V1 and T1 and V2 and T2. So we're solving for V2. So volume 1 is 3.75 mils of Cl2. For temperature 1, it is cooled from, so that is the first, so it's 75.2. That means T2 is 12.5. Now, for any question in chapter 6 where we're going to use the temperature, we always have to convert to Kelvin. So we're going to add 273.15 to this, and that's going to give us 348.4. And you'll notice that I have rounded this number, and I rounded to one place after the decimal because that's what we see in the calculation. So when we add two numbers together, we go based on how many points after the decimal place. So we're going to do the same thing for our other value of 273.15 plus 12.5, and that gives us 285.7. So now we're going to start plugging these values in. So we're going to have 3.75 milliliters divided by 348.4 Kelvin equals X milliliters divided by 285.7 Kelvin. So when we solve for V2, we get 3.05 milliliters. So if you were to do this without converting, you will not get the correct answer. That's because this calculation uses PV equals nRT. And so to do that, you need to make sure that you are utilizing the R value, and that requires your temperature to be in Kelvin.